Alright guys, so let's do a Bernoulli equation substitution problem because it also goes over linear as well. So this example I'm going to do looks something like this. Okay, and again for Bernoulli you want it to look like that. Okay, so if it looks like that, what am I doing here with this? Okay, if we could get it to look like that, then that's the form that we want. So what I'm going to do is just let's rearrange and distribute. So xy to the fourth minus y. So I'll get this Bernoulli equation is in the form that I like. Okay, so you can see like p of x is going to be 1 in our situation. Q of x is going to be x. All right, in this case we have n to be 4. Okay, so when this happens, we want to make our variable, so you can pick any variable, just not x and y, but if I choose, say, v, I'm going to pick y to be 1 minus n, so in this case v is going to equal y to the 1 minus 4, so y to the negative third, and we know y is going to equal then v to the negative 1/3. Okay, and now I have some type of substitution, but remember you do have to get something to substitute in for dy over dx, so take the derivative here. You'll get negative 1/3 v to the negative 4/3, and then remember it's with respect to x, so you have dv over dx. Okay, so now we could do our substitution here, right? I'll have negative 1/3 v to the negative 4/3 dv over dx plus my y, right? Y was v to the negative 1/3 equals x v to the negative 4/3. So you're plugging in and substituting in for dy dx and y, and your variables that should only be there are x and v. All right, once you do this, now we're going to divide everything by the coefficient. Okay, you want to divide everything by the coefficient. All right, so that way you get this into a linear form. So that becomes 3v equals a negative 3x. Okay, so just be careful of your division. You're dividing everything by that first value in front of, or that coefficient function in front of dv dx. All right, and now you can see that we have this nice linear problem. So let's go over linear. So just to point out, this is linear. Okay, so when you're doing linear, you want to find p of x. Actually, let's go over the notation. So it looks like if we're using y's and x, right, you have p of x like that. Okay, so here p of x is going to be negative 3, and then when you get that integrating factor, right, this is going to be e raised to the integral of p of x dx. So here we get e to the negative 3 dx, so my integrating variable is e to the negative 3x. Once we have that, you are going to take this integrating factor and multiply it through that equation, that linear equation that we set up. So it looks like this: e to the 3x dv over dx minus 3 e to the 3xv equals negative 3 e to the 3x, negative 3x e to the negative 3x. All right, and now with this, if you notice here, what's your derivative of e to the 3x is negative 3 e to the 3x, and then v, your derivative is dv dx. So this is just the derivative of your integrating factor, e to the negative 3x, and v. Here, let's just leave this the same for now. Okay, once we get down to that step, now let's take the integral with respect to x. All right, and over here I'll show you a little chart, integration chart, right? Pick your u, your dv, because this is by parts. Okay, and u should always be the easiest one. Like you should have, if you take the derivative of u, eventually keep taking the derivative, you get to 0. That's what you want to do with the chart. Okay, over here we have e to the negative 3x, whatever is left over, and now you're doing antiderivative on this side, so negative 1/3 e to the negative 3x, and then 1/9 e to the negative 3x. Okay. Also the signs, right? You start with a plus and then a minus, okay? And that will give us our terms, all right? So it'll look like this. So integral of a derivative, right? This just is gonna cancel out. So you have e to the 3x v equals, and now I'm gonna use my chart. So I have negative 3, actually, my bad. Let me show you how to use the chart. You're multiplying those two together, right, and those two together. So it's going to be negative and a negative on that first arrow, right, if I multiply those two terms. So I get a positive 3, actually, what am I doing? A positive 1x e to the negative 3x. The next one's also going to be a positive because you have the negative and the negative, and that's going to be a plus 1/3 e to the negative 3x. And don't forget your plus c. And now I'm going to divide everything by e to the negative 3x. Okay, so I'll get that, and then plug back what your v was, and we made v y to the negative 3rd. And I think you should be able to leave it like so. All right, there's a Bernoulli example. Hopefully that helps.